Good afternoon, all the participants. I am Vivek, AGM RTDC Hyderabad. This session is about SON introduction, and it's about 10th chapter. In this session, we will see what is SON concept and what is SON implementation and what are the various issues in it, SON data creation and automatic handover in SON. So these are the agenda points as per the E4 E5 material. So first of all, what is this SON? SON stands for self-organizing network. So what is this SON? SON, what is this technology? This is an automation technology. This is an automation technology in this mobile communications, which will automatically does the planning activity, deployment or installation activity, or operations like troubleshooting activity or optimization activity, and also the corrective maintenance of the network. So everything it will do it automatically. The purpose of SON, which is a 3GPP specification, from release 8, 9 and 10 it has been defined, so with some improvements, enhancements. So SON is an automation technology which is a collection of many functions. And you can see here automatic configuration is there. What is that? It is nothing but the installation activity. So after installation or after deployment, you will be having optimization issues that will be automatically done by the SON, and diagnostics, troubleshooting of the issues. If any faults occurs, if any BTS is down, if any core network elements are down, or any links are down, it will be diagnosed, and not only diagnosis and reporting to the concerned team, but also it will try to heal. Heal means do the corrective maintenance. So these are the various activities that can be done. So we can say a SON can do the automatic planning, automatic deployment, automatic operation, automatic optimization, healing of the networks. But of course, with the rider, when I said planning means not completely it will do the end-to-end or a complete deployment installation, then people will get doubt whether SON is a robot or what, which will do if it does everything, then what's the purpose of humans? So it will try to reduce the human effort to a large extent, and this is the major necessity in all the future mobile networks, basically to have the cost savings. What's the advantage of implementing the SON? So it will reduce the human intervention for the complex tasks for to a large extent, thereby reducing the capex and opex, capital expenditure and operational expenditure of every service provider, particularly in BSNL if it is implemented. So it will reduce a lot of human effort that will be done in the OMCR. Whenever complex procedures are done, configuration during deployment times, which are the routine tasks that can be automated and it can be doing the task. So what are the drivers for the SON? Obviously, as I told you, the complexity of the network and multiplicity of the technologies. We know in current BSNL or elsewhere, a lot of radio access technologies are there, starting from second generation, third generation, fourth generation, now fifth generation also. Pilot testing is going on by some operators in some countries, and also some operators have already launched in some countries, unlike in India. So that is the complexity. So many networks will be there, so many nodes. GSM will be having certain number of nodes, and 3G will be having different types of nodes. We know GSM BTS is different from 3G node B, and again 4G it's called E node B, and 5G it's called GNB. Likewise, several types of nodes are coming, and different network elements will be coming, and obviously parameters also, lot of parameters will be there. So manually, if you want to do any tuning or configuration, it involves lot of resources, time, cost, and money. So it will reduce for everything. And as we discussed, multi-technology, not only multi-technology, which we discussed, multi-vendor also. BSNL itself, we can see we for different phases of tender, we have seen yesterday so many so many vendors support is there for BSNL. We are having in AP in Telangana, if you see, we are having support of Motorola earlier, then followed by Nortel, then we are having support of Nokia, Siemens. So many vendors are there. Then before Nokia, Siemens, we are having Huawei, then Jetty, followed by Nokia, Siemens. So many vendors, multiple vendors will be there, and all the technology should be interoperable, and they should be interconnected without any issues. Ultimately, quality of service and quality of experience for the customer should not be a hurdle, and performance of the network should not be down. So these are the drivers for the NISON, and multi-layers, different layers are there, the access layer or the user layer and the core network layer. This is a complex set of network. These are the drivers for SON, so for automation. And the other reason is why automation is required. The traffic is also growing day by day because of the prosperity of e-commerce, mobile commerce, and then growth of the data, big data, due to social media explosion, and it may be the Twitter data or Facebook data or WhatsApp data, and now growth of the number of users also. So obviously when the traffic is growing like anything, capacity management is a very difficult task. Capacity management in the sense, in our network, so many technologies, so many nodes, so many base stations will be there. Some base stations may be having high load, some base stations may be having low load. And if you are managing the capacity in an efficient manner, then obviously at least whatever capacity that is there, that can be optimally utilized. So rather than wasting a low load network capacity, if you can adjust it with the high load requirement or congested network requirement, then we can reduce the loss of customers, and also loss of revenue also. So other one is to provide a consistent quality of service and availability. Downtime should be reduced, and of course there is a need for the knowledge base and interactive networks. So another requirement for today's automation technology is artificial intelligence. So with the use of the machine learning and the deep learning algorithms, the self-organizing network is automated with the multiplicity of the data that is available in the network. So mostly what SON is going to be done obviously in the SON. So a network with an SON capability, which will be having the design feature, building feature, and operation and maintenance feature, will be done by the self-organizing network. Okay. Here you can see the SON coordination is there. This is, you can say, SON and this is SON NMS. The SON NMS, the humans will be there, and of course by using the some automation procedures, they can do the design activity, building activity, and some maintenance activity. In the maintenance activity, you will be having self-optimization and self-healing. In the building activity, self-configuration of the parameters, maybe in the node B parameters, or maybe in the OMCR parameters. Of course, in the design process, again you will be taking the help of some planners for doing the radio network planning, but to an extent SON also will help in design process. So what are the benefits of SON? Just to summarize what we have discussed. So the SON tries to reduce the capital expenditure, so it will be used in planning activity and deployment activity. So initially for any service provider, planning and design and the installation is the initial activity, which requires a capital amount. Lot of investment is required. That capital expenditure will be reduced because of the SON, which performs the self configuration. And regarding SON's OPEX, it will also, as we discussed, the self-organizing network will try to reduce the operation expenditure during because it will perform automation of optimization, automation of the troubleshooting process. thereby it will reduce, and also energy saving activities also it will do. Okay. Self optimization means the drive testing which will be carried by the optimization team. The number of drive tests will be reduced. uh, as we discussed in earlier chapters, the drive testing normally which are done by the optimizers, no, now in SON it will be those drive test reports will be done by the UEs, our customers only. Our customers who will send the UE reports, UE uplink channel quality indicator reports to the eNode B. They will be no, collected, they will be captured in silos, they will be captured in a database, and they are processed, because the database will be consists of all the indicators. It will indicate the signal strength, it will indicate the quality parameter, it will indicate the SNR ratios, and all the required parameters which are required for the optimization. So self optimization, and thereby whenever any problem arises, self healing also will be done. Self healing means nothing but the corrective maintenance. Thereby it will increase the user experience. These all things will be will be done by the SON in real time. Dynamically it will performs it without the intervention of human. But of course the humans have to write the policies, they have to write the algorithms to perform the SON as per their requirement. So what is this SON concept? What you have to remember, SON functions will be classified into self configuration for installation and deployment, self optimization. No, self optimization, what is the purpose of optimization? To improve the coverage, to improve the quality, and to improve the capacity. And self healing is for the detecting the faults, or detecting any BTS fault is there, sector fault is there, cell fault is there, or any overshooting is there or undershooting is there, any outages are there. If there are outages of cells are there, how to compensate it? Well, yesterday I have seen hetero networks, how the heterogeneous networks can be operated, because the heterogeneous networks which are implemented in LTE release 10, it is capable of having multiple cell structure, and is capable of supporting multiple RADs also. Multiple cell structures means starting from femtocell to macrocell. So different cells, concentric cells are there. So if any cell is outage, the other cell or a bigger cell can take the load, thereby improving the quality of experience and thereby reducing the outages. How the SAN framework is there as per the 3GPP? 3GPP SAN framework is like this. So as we have seen that there are three functions: self configuration state, optimization, and self healing. And just let us see what are the various things that can be done in self configuration in detail. Suppose if you switch on a eNode B, eNode B is the LTE node B. LTE base station is called as eNode B. Whenever an eNode B is switched on, so what will be the SON functionalities means immediately configuring the IP address. Already the IP address plan will be available with the SON. What are the IP addresses plans that are there, and what is the scheme of IP addresses that can be allocated will be initially given to the SON NMS. So it will automatically configure an IP address to the eNode B, and it will automatically associate with the gateway, or no, which gateway the eNode B should be connected to the SDW, which SDW it has to be connected, which MME it has to be connected. So those it will be, it automatically it will create the route in the network, and it will perform the authentication, and it will be downloading the required software or the configuration data from the OMCR to load the eNode B. So these are the basic setup steps which will be automated by the SON. An initial radio network configuration which normally has a lot of problems, like neighbor list configuration. Whenever neighbors are not properly defined in the node Bs or the OMCR, we all know, and that in the chapter KPI reports also we discussed that whenever neighbors are not properly defined, handover failures will occur. So neighbor list configure manually, errors may be there. Whenever loading the neighbors, they have to check the radio network plans, and then the coverage plans, and then quality maps of the planners. The OMCR people, they have to check it and load it. So if there are any manual errors in the planning team reports, or the OMCR manual entries, or any scripting data, so that will be creating a lot of handover failures or network congestion. So these problems will be eradicated if you are configuring the neighbors automatically through SON. Some coverage parameters also can be configured. And then coming to optimization, of course, optimization also, neighbor list optimization, that can be done. We will see in a use case in the next slides. And coverage and capacity optimization. So whenever coverage is an issue, poor coverage is there, obviously if you are having the smart antennas, the antennas parameters, the physical optimization can be carried out. As we have seen, the physical optimization is nothing but changing the antenna parameters, the azimuth or tilt, or the EIRP of the antenna. So these parameters can be changed in order to optimize the network. And capacity optimization, the load adjustment, load balancing between the neighbor cells or concentric cells can be done to perform the optimization in a real time. And troubleshooting, self-healing, automatic troubleshooting, and not only automatic troubleshooting, but automatic recovery of the network. So initially the troubleshooting involves the failure detection or localization, which cell is down or which BTS is down. Is it because of a hardware issue? Is it because of the TRX fault, or is it because of any control card fault, or is it because of link failure, or is it because of any logical link failure? That will be diagnosed, and healing scheme will be the different trials which are written in the algorithm will be implemented and executed. So this is the framework of 3GPP. And just to summarize it, you can see it in our material. It is also given that these are the different areas where the SON will be implemented. Okay, so these are the different activities in the planning. It will automatically derive some few radio parameters for the E node B and reduce the amount of the manual activity. So self configuration will be having these features, and see, also you can see automatic configuration parameters involves initial PCI, the physical cell identifiers, and NRs, initial NR and initial PRAJ configuration. All these things are configured automatically. And IP equation, which you have seen, automatically IP will be configured. Neighbor list configuration, automatic connectivity establishment, the link establishments, and self testing and software down. These are the various activities in deployment. Coming to the optimization, again as we discussed, the neighbors optimization, mobility, the handovers, and then load balancing, RACH optimization, and coverage and capacity optimization. These are the various activities in optimization. And healing, outages, detection, and compensation. So these are the various activities of the SON, which is automated by the 3GPP standard. So as per the 3GPP standard, these are all automated activities that can be implemented by any service provider across the world. So self configuration, as I told you, all these activities involves in algorithms should be written in the background to implement these networks. And if you implement this self configuration of SON, the advantage is the networks, whatever nodes you will be implementing, they can be like a plug and play. Plug and play means, for example, if you want to install, if you want to connect, use a new web camera, new camera in your desktop PC, simply you bought a new cam and connect it to your USB port, and automatically if you open the webcam, it will work. So what is happening? Automatically you will be having a software in it, and auto loading will be done. Auto loading of the driver software will be done, and the functionality is called as plug and play. So whenever you are buying a new keyboards or mouses or new any peripheral device to the computer, we can see that they are automatically loading their driver software, and they can be played immediately, they can be used. So plug and play functionality, just like the peripheral devices or input output devices which we connect nowadays to the PCs and how they function. Similarly, the network elements like node Bs or SDW, all these basically the node Bs, which are will bulk in number, so they will be they can be implemented in this fashion. Another distinct functions of self-configuration is automatic software downloads, etc., and self-testing of the eNode B. And as we know, in 4G, there will not be any frequency planning, because all the cells will be using same frequency. OFDMA is implemented, but what is the unique identifier which is allocated to each and every 4G cell is nothing but PCI. PCI planning is done by in the 4G. So 4G, of course, PCI planning is not so difficult like RF planning in GSM and 2G. So, but these physical identifiers, physical cell identifiers, will be automatically configured by the SOI network. And also the neighbors, ANR, automatic neighbor relations. Automatic neighbor relations means, in order to perform the handover, as we know, every cell should know what are its neighbors. Otherwise, what will happen? The handovers will be failed, the call will be dropped. No neighbors definitions means no handovers, the call will be dropped. So every service provider or every optimizer, they have to ensure that every cell should record in its OMCR, in its database, in the network database, while it's broadcasting the data in every node B. The neighbor information should be stored in the neighbor list. So automatically neighbor relations will be found based on the upload data of the UEs, and this is called self-configuration. So self-configuration, apart from it, self-configuration also has other self-discovery functions like detection of the transport type. It will also detect whether TMA is there or not. So TMA means tower mounted amplifier, in order to boost the signal, to provide the long coverage, maybe in highway areas, or maybe in areas where you are having coverage issues, you can use TMA. So the in the self-configuration feature, whenever you power up in the eNode B, it will be all these things will be discovered automatically. So antenna cable length, how much antenna cable length is there, any VSWR faults are there or not, and if they are detected the eNode in the eNode B logs, they will all be certain, they will all be collected, and they will be utilized with algorithms to do the configuration activity, and auto adjustment of the receiver path. You can see these are the various steps of self-configuration. So whenever you take a eNode B, power it on, the first step will be IP address allocation. Automatically IP address allocation will be done by the SON network, and then after IP address allocation, it has to be connected to the gateway, SDW. So second step will be the association with the gateway, and the third step will be the authentication. The authentication, eNode B should be authenticated, and the eNode B information should be, information like the software and parameters should be downloaded, and after downloading of the data, the transport and radio configuration will be done. This is automatically, and then after radio configuration of the eNode B, then it will be connected to the OAM function, that is OMCR. So it will be connected to the OMCR. So after OMCR connectivity, for OAM activity, so this will be the setup will be done. What setup? X2 setup will be done. X2 is the interface between the neighboring eNode Bs. So between the neighboring eNode Bs, the OAM will be instructing to do the self configuration. So X2 will be set up, and then your network is ready to be used by the users. So these are the various automatically done by the self configuration procedure of SON. Apart from that, as I told you, PCI in self configuration, PCI allocation up to different cells also will be done. PCI is an important parameter that should be allocated to every cell. So it will also satisfy two rules by allocating the PCI. It should be collision free and confusion free. See, what is the collision free? The PCI of one cell should not be same as neighbor cells. So all the PCI should be unique. Every PCI which is allocated to the neighboring cells should be unique. So that is the care you have to take. Otherwise, if the PCIs are same, there will be interference. And PCI of the neighbor cells should not be the same. Neighbor cells should not be the same, and the PCI of one cell should not be the same as those of his neighbor cells. So these are the two things we have to take care while configuring the PCI, and these rules are implemented in the SON self configuration algorithm. After self configuration, another feature that as we have seen, it is self optimization. Obviously, what is the purpose of optimization? To improve the network quality and performance of the operator. And self optimization of SON will reduce what? It will reduce the manual intervention. So human effort will be reduced and improves the network performance. How it is doing it? How it is doing means it will analyze all the performance data. As I told you, the performance data it will collect from the UEs, and it will collect from the different nodes, and whenever any activity is detected, whenever any outage is detected, whenever any anomaly is detected, whenever any issue is detected, it will find out that activity and address the problem. Okay. It find what it is doing, it is reducing the manual interventions with automatic adjustments of the parameters. So in self optimization there are several use cases. In self optimization of SON, what are the various activities it can do? What are the various activities it can do? As we just seen, it can perform the physical cell identifier allocation, it can allocate the neighbors, and it will another activity it can do is ICIC. This also we discussed in the 3GPP releases chapter, which is a feature of release 10 and 11. ICIC is nothing but inter-cell interference coordination. As in 4G OFDMA is used, and you will be having inter-cell interference at the cell edges that will be eradicated, and it can be addressed by using ICIC feature. And an ICIC feature can be implemented automatically by self-optimization of SON. Apart from it, mobility robustness optimization is nothing but mobility handover optimization. This also automatically, mobility means the mobile phones has a feature of mobility, moving from one place to other place, still the mobile phone works. That feature is nothing but what is that? In order to if you are providing handovers, only then feature can be implemented. So mobility robustness means nothing but handover robustness. And how to optimize it? Of course, the neighbors should be properly defined, the coverage should be there, and the quality should be there, and parameters of the handover should be properly defined. These can be done to an extent it can be optimized automatically by SON self-optimization activity. Another important optimization will do is mobility load balancing. It's not that SON will be doing everything activity of an optimization, but these are the major activities that are defined. Load balancing activity also. Load balancing between the concentric cells or among the neighbor cells, it can be performed. So neighbor, I just told you how automatic neighbor relations will be established by the SON. The ANR relies on the UEs. This we discussed it to detect the unknown cells and report them to the e-nodes. So automatically addition of deletion of neighbor cells will be done by the SON, and of course what are the various activities that are involved to do the ANR function? It will do the measurements, it will detect the missing neighbor, and it will report, it will take the decision to add or delete and update the network. How it will be done? Let's see the picture. See here, this is a eNode B which we are talking about, and this eNode B is having a PCI of 1 and eGCI means enhanced or evolved global cell identifier 20, and for another node B, eNode B, PCI is 2 and eGSI is 30. See, eNode B is there. Suppose a customer, we have taken a customer, a user at the cell edge, and this customer is getting its coverage from eNode B, and let's take a case that he is tending to move towards this one, and suppose this PCI2 net is not defined in this eNode B PCI1, then what will happen? If the neighbors are not defined, when the customer is moving towards this direction, the call will fail, call will drop. So how this will be detected? The ANR, it will be doing the UE measurements. Even though it is not noted, even though this neighbor information is not recorded in the OMCR, but this UE will detect whenever it is going towards this direction, the UE will detect this signal. See, for what's happening, the UE first detects the signal PCI2, and then what it will do? It will be, the PCI will be in RRC uplink measurement report. It will be sending the report to the network. It will be sending the report to the network, and what will happen? This network will report back to the CPI, to the mobile phone, and it will ask the ECGI. ECGI means the cell global identifier. And now what will happen? Your UE will read the BCCH information in the ECGI. So it will read the BCCH information. In the BCCH information, you will be having the ECGI of 30. Okay, and this information will be reporting back through RRC measurements to the network. So then what will happen? Your network will be asking the TNL address, the transport network layer address, in order to establish the link with the ECGI, new ECGI or the new node B. Okay. And this in NR table, in the neighbors table, this information is recorded. Entry is made now. What entry? The PCI2 entry is made. You can see this is the red line. In this red line, the new entry is made in the eNode B. And after new entry is made, what is happening? This eNode B is establishing a link between the new eNode B. Establishes what link? X2 interface between the neighbors cells, neighbor eNode B's. LTE defines X2 interface to have faster handovers and load balancing and other features. So by this you can see automatically ANR will be updated by doing all these 8 steps. So this is the facility in SON. Apart from ANR, another feature that is there, as we have seen in self-optimization, ICIC. ICIC, as I told you, it will reduce the cell edge it will reduce the cell edge interference problem, so thereby improving the cell edge performance, and that is a major advantage of ICIC. So how ICIC is based on? ICIC is normally based on physical resource block, PRBs. Okay. The ICIC implementation by SON, it will be implemented by coordinating by utilization of available PRBs. So PRBs are the physical resource blocks of OFDMA. In OFDMA, the users will be given resource in terms of PRBs. Certain number of PRBs are associated with a certain number of cells. So these, what are to be restricted, what PRBs are to be restricted, what PRBs are to be prioritized, basing on the requirement, basing on the interference issue at the cell edges. Thereby, if you implement ICIC, the SIR, the signal to interference ratio, will be improved, and thereby the throughput also is increases. And ICIC, how it is implemented through RRM mechanisms, radio resource management mechanism. And another feature in self-optimization of SON is MRO, mobility robustness optimization. The mobility robustness optimization, as I told you, automates the handover. If you improve the handover operation, what will happen? Obviously, no call drops, so end user experience will be improved, and the network capacity also improves because no call will be dropped. Mobility feature can be given. The capacity also gets improved. The handover failure. So, what are normally the handover failure categories which SON can address? The failures due to too late handover triggering, failures due to too early handover triggering, or failures due to handover to a wrong cell. So, let's see how the pictorially. So, too late handover. So, the customer is moving, let's say, from E node B to E node B2, and the customer is moving towards E node B2, but the call is not handed over, and call, what will happen? It will drop and will try to re-establish, but the call, the quality of experience will be poor. Too early handover. So, too early, in this case, you can see here, this is the wrong cell handover. In the wrong cell handover case, customer is moving from E node B towards E node B3, but the customer is handed over to the wrong E node B. And apart from the different use cases, we can see what are the requirements of the 3GPP in implementation of MRO feature by the SON. What are the requirements? Means it should be automatically, the ANR should be automatically configured, all the parameters should be automatically captured from the ONCR, and it should implement it. And also the SON should configure valid range of values for these parameters, and it should be the vendor specific algorithms for handover parameter optimization. So, these are the requirements of the 3GPP. When this MRO feature is introduced, in release 10 for the purpose of detecting the unnecessary inter-RAT handover from 2G to 3G or 3G to 4G or 4G to 2G. These are the unnecessary inter-RAT handovers. So, reduces, what's the purpose? Reduces the need of extensive drive testing. We discussed it, and especially it is useful in HETnets, heterogeneous networks. In heterogeneous networks, we will be having, there which are more dynamically, the cells are adjusted depending on the load requirement, depending on the mobility of the customer. If the load is high, small cells appear. If the load is less, they will disappear. And the number of cells, whenever you are having small number of cells, the number of cells will increase. So, if the number of cells will increase, obviously the MRO will be more important, because more the number of cells, more the parameters, more the number of locks will be there. So, what is the best solution to do the when the number of cells are more, obviously number of handovers are more the number of handovers, manual intervention will be difficult and time consuming process, and if you automate that process through MRO, it will improve the system performance. Another important, as we have seen, the MLB feature in SON, mobility load balancing optimization, which is also very important, wherever you are having low load node Bs, and they try to compensate the congested E node Bs. Okay, and this will be performed intelligently. It will spread the user traffic automatically basing on the available resources. And obviously, what will happen? The end user experience and performance will increase. So, the shaping, automatically the shaping of the system load will be done, of course, as per the operator policy, as per the algorithm you define. Okay, other important activity that will be done by the load balancing, even it will be turning off the low loaded cell or lightly loaded cells will be turned off to save the energy. So, energy saving activity also will be performed by the load balancing. So, load balancing functions, what are the MLB functions? The algorithm will be doing these three functionalities. Load reporting will be done to the SON NMS, and handovers, which will report the number of handovers, and it will adapt the handover parameters also. So, MLB functions, what it will do by between different cells, it will adjust the load between the different cells by adjusting the handover thresholds automatically. And MLB function will be coordinating with the MRO. They should be coordinating with each other in order to perform the handovers and load balancing. Okay. Even the MLB feature is required for the ideal users. Ideal users also is required, but this is more difficult task than active users, because ideal users, when ideal user information will be known to the network only during the tracking area update. During only whenever the tracking area update message is sent by the UE, then only network is aware of the UE, whether it is in idle mode or in active mode. So in the latest implementation, even in the idle mode also, the MLB feature is done. How it will be done? By adjusting the cell reselection parameters. Okay, cell reselection parameters. And the different ways of implementing this MLB. So we can activate the MLB feature of the SON whenever the network or cells are congested, or you can also keep it in at all the times. So either you can use this MLB during the congestion time or at all the times. And finally, how the CCO is implemented by the this SON. CCO is nothing but coverage and capacity optimization. The purpose is to improve the coverage and capacity. How the CCO is implemented? The network operator will be loading the performance targets and the policies of the their company, and then the SON will determine, the CCO will determine what is the optimal or optimum antenna configuration and RF parameters, such as the uplink power control parameters, or maybe the antenna power, or maybe the node B power transmission, or it will be determining what is the SNR requirement, etc. And for a specific traffic situation, and automatically the coverage and capacity will be adjusted. Okay. And these algorithms will be operated continuously, gathering the measurements and executing actions. Since the coverage and capacity is a long term, it's not a short term thing, it's a slow process where the decisions are made basing on the long run statistics, rather than doing in real time. The mobility feature, the traffic conditions may vary. Rather than doing it in a real time, if it is done in a long run statistics, will be more foolproof. So functions of CCO algorithm, they can be addressed for E-neutron, means evolved UMTS terrestrial radio access network. This E-neutron is nothing but 4G RAN, coverage holes with 2G or 3G, coverage holes with without any other coverage holes with isolated island coverage holes with overlapping sectors. So these are the various functionalities the CCO algorithm can address to reduce the coverage issue. And another important optimization activity the CCO and then SON can be doing is RACH optimization. As we know, a random access channel is required to make the channel request. These are the very important channels, control channels, and these are required to improve whenever RACH performance is good, the call setup success rate will be better and handover success rate will be better, obviously. So how it will be optimized? It will be monitoring the current conditions. What it will do, it will see how the RACH load is increasing. The SON will observe if the RACH load is increasing or not. If RACH load is increased, it will adjust the parameters. So the more RACH load is there, obviously it will allocate more resource elements, more PRBs for the RACH, or it can dynamically change the capacity of the control channels. And it will also measure the uplink interference. It will see uplink interference, and thereby it will reduce the capacity required. RACH optimization benefits, short call setup delays and short handover delays, and the reduced connection time. Obviously the throughput will be increased, coverage and capacity also increased. So these are the advantages of the RACH optimization, and it will be done automatically by the SON. And the SON will also, as I told you, it will reduce the operational expenditure. Operational expenditure reduction, includes sustainable development in the long run. So it will do lot of energy savings. By switching off low load networks, and it will reduce the power consumption, and it will also sometimes dynamically temporarily power off the unused capacity, and also works on the power amplifiers depending on the power coverage requirement. Power amplification also is dynamically tuned, thereby the inter-RAT energy savings will be there. E node B, intra E node B savings will be there, inter E node B savings will be there. So this will result in lot of saving of operational expenditure for the operator. So coming to the last feature of the SON, this self healing, which is the most important one. The troubles can be detected, the faults can be notified, but automatically corrective maintenance is the most sought after by the operators. So not only detecting the problems is the one issue, but it will solve or mitigate the problems, but thereby reducing the maintenance cost. And another thing is involving automatically it will detect and automatically it will restore. How? By using the algorithms, the SON algorithms. Okay. And of course, by triggering some alarms, just like our regular OMC alarms, how they will be notifying through SMS or through WhatsApp messages, it will alarm the concerned staff. So areas where it can do, it can it will be doing the self diagnosis. First, initially self diagnosis is nothing but detection of the fault. By using ML algorithms, by using different regression models, it will diagnose and and learn from the past experience of the past data. And self healing will be, self healing means automatically doing the corrective maintenance. So self healing SON functions, as I told you, cell outages can be detected, and self recovery of the network elements, and self healing of the fault. Board faults means hardware faults. Cell outages detection, here not only detection but compensation, as we told. Automatically it will detect the faults and automatically it will compensate to restore the normal service, and the SON will temporarily mitigate the problem. How the SON architecture will be there? The SON can be implemented in three ways. One is centralized manner, other one is distributed manner, other one is hybrid manner. In centralized SON, if you see how the centralized SON will be there. Here you can see these are the E node Bs in the network. The E node Bs will be connected to the OMCR. These are the OMCR, and of course centralized OMCR will be there. Maybe let's say these are at the district headquarters and these are at the circle headquarters. And you can see that every OMCR is having a SON capability. SON algorithms are implemented in the OMCR, centralized manner. So all the currently we are having the centralized OMCR concept in our BSNL network. Similarly, this can be implemented. Coming to the distributed SON architecture, there you can see now it's the SON software is not implemented in the OMCRs, but they are implemented in the E node B itself. E node B is implementing SON means implementing the SON software in all the E node Bs that are available. This is little TDM task, because loading the SON in all the E node Bs requires more time, and but if you require more efficiency, this can be done. But if you want to have a trade-off between two advantages, you can have a hybrid SON. Hybrid SON has the facility of implementation in the centralized OMCR and also in the E node Bs. You can see the SON feature is there everywhere in the OMCRs, district circle OMCR, district OMCRs, and in the field E node Bs. Okay, this is hybrid SON. And when this SON has appeared in the 3GPP specs, right from release 8, it is there. Release 9 enhancements are there. Release 10 is also there, and beyond also new releases of 3GPP also SON enhancements are coming up. So what are the different SON activities? Release 8, you can see whatever automatically software downloading, automatic self configuration is there. ANR and PCA selection and MLB feature is came up in release 8. And in release 9, what came up is the ANR configuration and data preparation, self optimization, load balancing, and MRO feature, and RACH optimization, CCO and ICC came up in release 9, which we have discussed before. And in release 10, the main thing is the self healing has come. Okay. Self healing facility is not there in release 8 and 9. Self healing, that is cell outage detection compensation, which we discussed, came in release 10. And our energy savings option also came in release 10. And eICIC, enhanced ICIC feature, and minimization of MDT feature came in release 10 SON. And in release 11, this is Utron SON management of ANR, automatic neighbor relations detection, and SON coordination management, and inter-RAD energy saving, and further enhancements to the MRO and energy saving has come in 11. So of course 8, 9, 10 are more important. 11 is some add-ons to the 10. In release 12, also some add-ons to the CCO, centralized CCO concept has come, and mainly the plug and play concept, multi-vendor plug and play eNodeB has come. Irrespective of the vendor, the eNodeB can be plugged and played directly. It can be without any configuration, without any manual configuration or downloading of the data. Automatically SON will take up all the self configuration activity of the eNodeB. So with this we have seen the various releases of 3GPP SON, and we also have discussed in detail regarding all the self-organizing network. Thank you very much.